Hey guys, welcome to the next video on OpenCV tutorial for beginners using Python. In this video, I'm going to show you how you can create a very basic and simple motion detection and tracking system using Python and OpenCV. So let me show you what we are going to achieve at the end of this video. So I have this video, which is a sample video, and you can see some people are walking around inside this video. Now what I want to do here is I want to show these rectangles around these moving people or persons. So this is tracking, and when some movement occurs, I also want to show this kind of status. That status is movement because somebody is moving inside the video. So if nobody is moving, this status will be blank, and if somebody is moving, then this status will be movement. So this is what we are going to achieve at the end of this video. So we are going to try to track each and every person, and also we are going to track this person with this rectangle, and also we will show the status as movement when somebody moves inside the video. So let's get started. So to start with, I have this basic code which just reads a video using video capture class, and then if this video is valid, then I'm going to just show this frame by frame inside I'm show window. And I'm sure you might be knowing all this code because I've shown you step by step how to capture the video or how you can read the video frames using video capture method. Okay, so this is just to load this video and show it frame by frame using ImShow method. So let me run this code first of all to start with. So our original video looks like this. So some people are moving, but we want to track the movement of each and every person, and also we want to show a rectangle around them, whoever is moving. So let's get started. So under this video capture code line, what I'm going to do is, first of all, I want to read 2 frames from the cap instance. So I'm going to just copy this code and paste it here. So this will be our frame 1, let's say, and similarly I'm going to just read the second frame. So simply we are just declaring 2 frame one after another. Okay, and we don't need this code anymore. So first of all, I'm going to declare a variable diff, and using cv2.absdiff method, so absolute difference, we are going to find out the difference between the first frame and the second frame. So this method absdiff is for finding out the absolute difference between the first frame and the second frame. Now once we have the difference, then we are going to convert this difference into a grayscale mode. So we are going to just say gray is equal to cv2 dot convert color, so cvt color, and the first parameter here will be our difference which we have found between the 2 frames. So I'm going to just pass diff as the first argument, and the second argument will be cv2 dot, we are going to convert this bgr color to the grayscale mode. And why we are finding out the grayscale mode of this diff? Because we are going to find out the contour in the later stages, and in the last video we have learned that it's easier to find out the contours in the grayscale mode as compared to the colored mode or the BGR mode. So once we have this grayscale mode, we are going to just blur our grayscale frame. So we are going to just declare a variable called blur, and then we are going to apply the Gaussian blur on our gray variable. So CV2 dot Gaussian blur, the first parameter here will be gray. So let's give this gray parameter which we have defined here. The second parameter here is the k size or the kernel size. So let's say we want to provide the kernel size 5,5, and the third parameter here will be the sigma x value. So we are going to just pass 0 here as the sigma x value. Now we are going to find out the threshold. So we are going to just say underscore because we don't need this first variable, and then the second variable will be thresh is equal to cv2 dot threshold, and the first parameter which it takes is the source. So we are going to pass our blurred image as the source, and then the second parameter here will be the threshold value. So we are going to just provide 20 here. Then the maximum threshold value will be 255. Then the type will be cv2 dot thresh binary. So in the next step, what we are going to do is we are going to dilate the thresholded image to fill in all the holes. This will help us to find out the better contours. So there is a method called cv2.dilate. So we are going to just declare a variable called dilated, and then we are going to apply this method. So cv2.dilate, which takes few arguments. The first argument will be our thresholded version of the image. The second argument here will be the kernel. So kernel, let's say for now we are going to provide none here. Okay, so the kernel size will be none, and then third parameter will be the number of iterations. So let's provide the number of iterations, and the number of iterations we are going to provide here will be 3. So if it doesn't work, we can increase or decrease the number of iterations. Now in the next step, what we are going to do is we are going to find out the contour. So as you all know that contour or find contour method is going to give you two results. One is the contours and other is the hierarchy. So we are going to just say contour, and the second result we are going to just say underscore because we are not going to use this second result. And then we are going to just say cv2 dot find contours, and we are going to find the contours on this dilated image. So we are going to say dilated. Now the next argument here will be the mode. So the mode which we are going to use here will be retter underscore tree. So I'm going to just write retr underscore tree, which is most commonly used. And then the next argument here will be the method. So the method here will be cv2 dot chain approx simple. And once we have our contours, we are going to just draw the contours because we already found out the contours. So we are going to just say draw contours, and the first argument here will be frame 1 because we want to apply all the contours on the original frame, right? So we are going to apply all the contours which we have found using all these methods on the frame 1, and then the second argument here will be the contour. So you can just give the contours here, and the third argument here will be the contour ID. I can just say -1, which is going to apply all the contours, and the next argument will be the color. So let's say we want to provide the green color. So I'm going to just say 0, 255, 0, and the next will be the thickness. So let's say we want to provide the thickness of 2 here. So now it's going to draw all the contours which we have found with the difference of frame 1 and frame 2, right? And then we are going to just display this frame 1. So we can just say this is our feed, and the result after applying the contour will be saved in the frame 1, which we will display. Now in the next step, what we are going to do is we are going to assign the value inside frame 2 into frame 1. So we are going to just say frame 1 is equal to frame 2, and then inside our frame 2 we are going to read a new value. So we are going to just say ret comma frame 2 is equal to cap dot read. Okay, so we are reading the new frame in the variable frame 2, and before reading the new frame we are assigning the value inside the frame 2 to the frame 1. In this way we are reading the two frames and finding out the difference between the two frames. So let's run this code and let's see if it works or not. Let's test this. So you can see now there are these contours which are drawn around all the moving persons. Also there are some contours which are drawn around this rope which is also moving, right? So we have successfully determined the contours and we have already drawn these contours on the frame 1. But this was not the result we are looking for. We want to draw the rectangle around these moving persons, and also we want some noises to be removed. So we don't want to draw the contour on the moving rope, let's say. Okay, so how to remove these noises and how to draw these rectangles, let's see. So now in the next step what we are going to do is, under or before we are drawing these contours, we don't want to draw the contours now. We want to draw the rectangles, right? So what we are going to do is we are going to iterate over all the contours. So we are going to just say for contour. So from contours we are going to find out contour in contours, right? So this is the list and we are iterating over this list. So inside this for loop, the first step will be to save all the coordinates of the found contours. Okay, so we are going to define the x coordinate, then the y coordinate, and then we are going to just say width comma height. And there is a method called bounding rect which we are going to apply on the contour. So we are going to just say is equal to cv2 dot bounding rect. This is the method which we are going to apply, which is going to give us the x and y coordinate and the width and height, right? And we are going to apply this bounding rect method on the contour which we are getting using this contours list. Now in the next step we are going to find out the area of the contour, and we are going to just say if this area is less than certain value, then we don't want to do anything. We don't want to draw a rectangle or anything. We just want to continue. Otherwise, if this contour area is greater than let's say some kind of a person's area, then we want to draw a rectangle on it. So inside this for loop we are going to just define a if condition. So we can say if cv2 dot contour area. So there is a method called contour area, which is this one, where we can pass our contour. So we are going to pass our contour, and if the area of this contour, let's say, is less than 700, then we are going to just say continue. So this code essentially mean that if the area of the contour is less than 700, then we are going to do nothing. We don't want to draw any rectangle. Otherwise, if the area is greater than 700, then we want to draw the rectangle. So we are going to just say cv2 dot rectangle. We have already learned how to draw a rectangle on an image using the rectangle method. the first argument here will be the source, which will be frame 1. The second argument will be the point 1. So we are going to just say point 1 will be x comma y. The third argument will be point 2. So we are going to just say x plus w comma y plus h. The next argument will be the color. So let's say the color will be the same 0 comma 255 comma 0. The next argument will be the thickness. Let's say we want to give the thickness 2, as we have done with the draw contour. We have provided the thickness of 2 here, right? Now in the next step, we are going to just print some text on the image if some movement is observed. So we can just say cv2 dot put text. This also we have seen in the previous videos how to put text on an image. So this time the source will be our frame 1. The second will be the text. So we will just say status, let's say, and if there is some movement, we are going to just say colon in the curly brackets. We are going to just use the format method. So this is just formatting the result using the string, and we are going to just say movement. The next argument here will be the origin. So where we want to put this text. Let's say we want to put this text on 10 comma 20 coordinate, and then the next argument will be the font face. So we are going to just say font face will be cv2 dot font Hershey simplex, let's say. So we are going to use this font, and the next argument will be the font scale. So let me just do this on the next line. So font scale will be, let's say, 1. The next will be the color of the font. So let's say the color will be 0 comma 0 comma 255, and then the last argument will be the thickness. So let's say the thickness will be 3, and this code is going to put the rectangle around your moving persons if the area of that contour is greater than 700. Okay, so let's run this code and let's see if it works or not. So I'm going to just run this code, and you can see that status is movement because all the persons here are moving, and you can see these rectangles which are drawn around the moving persons, and this noise which we were seeing in the previous result is also gone around the movement of this rope. Okay, so sometimes this rectangle is drawn on the movement of the rope also. So in this case you can also increase the expected area. Let's say we just want to find out the contours which are greater than 900, and we can now you can see these rectangles are drawn around these moving persons with the area which have the contour area more than 900. So you can remove these kind of noises from the frame using this area. So this was a very basic example how you can detect the motion and track your moving object inside your video using Python and OpenCV. I hope you have enjoyed this video, and I will see you in the next video.